All right, we're going to continue with section 14.2. Let 14.1, I'm sorry, not 14.2. Let F be continuous on a planar region capital R. The double integral. So now we're actually going to see how we set up these integrals over those type 1 or type 2 regions. The double integral of F over R, excuse me, denoted the double integral over R of f of x, y, d capital A is given by the double integral over R of f of x, y with respect to capital A, or with respect to area, however you want to read that, equals the integral from A to B of the integral from g sub 1 of x to g sub 2 of x of f of x, y dy, close those parentheses, and then dx, where R is a type 1 region. R is a type 1 region. All right, so let's put this in a little bracket or something so we don't confuse the type 1 region with the type 2 region. And the double integral over R of f of x, y dA equals the integral from C to D, in parentheses, the integral from h sub 1 of y to h sub 2 of y of f of x, y dx, in close parentheses, dy, where R is a type 2 region. So some things to make note of here. Constants always go on the outside. The parentheses indicate you do that integral first. So then you do whatever's on the outside after that. So you evaluate this integral. Notice when you have dy, that means when you look at your bounds, there are no y's in these bounds. It says a function of x, a function of x. So that means you're going to have dy back here. No, when you have dx, there should be no x's in your bounds. So that's kind of, if you were looking at an integral that was already set up for you, and you had x's in the bound, x in the bounds here, which would be this scenario up here actually, you know that they were integrating with respect to y first, and then with respect to x afterwards. So please make sure you keep that in mind, that constants have to go on the outside. And because you're going to be setting these up, when you set this up, when you put those functions of x there, you know it's going to be dy right there. you put functions of y right there, you know it's going to be dx. So now a couple of other notes about these two integrals. So first, and this is just because you're going to see this terminology in your textbook. So the right-hand side of the above equalities is called an iterated integral. It's called an iterated integral. As we evaluate the inside integral first. So if we go into iterations, we do the inside integral first. Hence the parentheses, and I'm sure I'm spelling parentheses wrong because I always do, but you all can correct it. I don't know why I can't get that right. Then we evaluate the outside integral. Of the result of the inside integral. So same thing that you are accustomed to with the parentheses. You do the parentheses first, and then whatever you do, whatever's left after that of the inside integral. Now, two other probably more pressing comments over that comment right there are to help with the valuation. So first one, and we'll put asterisks next to these. We must proceed in the order outlined and the bounds of the outside integral must be constants. Must be constants. So this is like a definite integral from calculus 1. Like you should end up at with a number at the very end. The next thing, this is going to be especially important. So when integrating with respect to x, we treat y as a constant. We treat y as a constant. And when integrating with respect to y, we treat x as a constant. All right, so a couple more notes and then we'll look at some examples after we finish the last note or two. Actually, you know what? What we'll do is we'll stop this video here, and I want to go into examples because I don't want to run out of time with the examples. The other couple of notes, I'll address them as we go through some sample problems.